everyone, in this video I'm going to present problems regarding trigonometric function, exponential function, logarithmic function, and maximum value.
Before we will proceed to our problems, familiarize the differential rules of the trigonometric function, exponential function, and logarithmic function.
So the first equation that I've prepared is y equals cosine raised to 3 sine 5x plus 1. In this equation, we will apply the chain rule. So we have y prime equals 3 because we pull out the 3, cosine sine 5x plus 1 raised to 2 because 3 minus 1 is 2. Then we will multiply it to the derivative of cosine sine 5x plus 1. So we have y prime equals, copy the equation, 3 cosine sine 5x plus 1 raised to 2, and the derivative of cosine sine 5x plus 1 is negative sine 5x plus 1. And the derivative of the inside is cosine 5x plus 1. And the derivative of 5x plus 1 is 5. So our final answer is negative 15 cosine raised to 2 sine 5x plus 1 sine 5x plus 1 cosine 5x plus 1. Our second problem is about the derivatives of logarithmic function. So we have y is equals to 2x minus 5 raised to 4 as numerator and 3x plus 1 raised to 3 as our denominator. In this problem, I used quotient rule. I applied differentiation to the both sides of the equation. Realize that if y equals to the natural logarithm of any u and y prime is equals to the derivative of u over u unchanged. So we have natural logarithm of y equals 4 times natural logarithm of 2x minus 5 minus 3 times natural logarithm of 3x plus 1. Next is we have the derivative of natural logarithm of y is y prime over y unchanged equals 4 times the derivative of natural logarithm 2x minus 5 is 2 over 2x minus 5 minus 3 times the derivative of natural logarithm of 3x plus 1 is 3 over 3x plus 1. Then we have y prime over y equals 4 times 2 is 8 over, copy the denominator, 2x minus 5 minus 3 times 3 is 9 over, copy the denominator, 3x plus 1. At this point, we will find the common denominator of the two fractions. So we have the 2x minus 5 times 3x plus 1 as our common denominator. So we have y prime over y is equals to 8 times the quantity of 3x plus 1 over 2x minus 5, 3x plus 1 minus 9 times the quantity of 2x minus 5 over 2x minus 5, 3x plus 1. And then we will distribute the numerator. So we have y prime over y is equals to 24x plus 8 minus 18x plus 45 over 2x minus 5, 3x plus 1. Next is y prime over y is equals to combine like terms. So we have 6x plus 53 over 2x minus 5, 3x plus 1. Then we will multiply the both sides of the equation by y that will serve to eliminate the y. Then we have y prime is equals to 6x plus 53 over 2x minus 5, 3x plus 1. So the next step is we will go back to the original equation, which is y prime is equals to 2x minus 5 raised to 4 over 3x plus 1 raised to 3, and we will multiply it to the 6x plus 53 over 2x minus 5, 3x plus 1. So our final answer is y prime is equals to 2x minus 5 raised to 3, 6x plus 53 as numerator, and 3x plus 1 raised to 4 as denominator. So let's move to our third problem. It is a mix of exponential function and logarithmic function. So our problem is y is equals to e raised to sine 2x over the quantity of ln cos 2x raised to 2. In this equation, we will apply the quotient rule, chain rule, and power rule. So we have y prime is equal to the quantity of ln cos 2x raised to 2 times e raised to sine 2x, then the derivative of sine 2x is cosine 2x times the derivative of 2x is 2, minus e sine 2x times, we will apply the power rule, so we have 2 ln cosine 2x raised to 1. Then the derivative of natural logarithmic cosine 2x is 1 over cosine 2x. Then the derivative of cosine 2x is negative sine 2x, and the derivative of 2 is 2 over the quantity of ln cosine 2x raised to 4. Then we have y prime is equals to ln cosine 2x e sine 2x to the quantity of cosine 2x ln cosine 2x plus 2 tan 2x over the quantity of ln cosine 2x raised to 3. We will simplify this equation to get the final answer. So our final answer is 2e raised to sine 2x, the quantity of cosine 2x, ln cosine 2x plus 2 tan 2x over the quantity of ln cosine 2x raised to 3. So for our last problem is about maximum and minima. A pencil is limited to 20 feet length. What is the maximum rectangular area that can be fenced using two perpendicular corner sides of an existing wall? So we have here an illustration that concerns the two perpendicular corner sides of the wall. So I made an equation using the conditions of my problem. So length plus width equals 20. Now, what is the maximum rectangular area? We have the area equals length times width. Now, we can say that width is equals to 20 minus L. Now, we can say that we are maximizing the area. So, we will get the area in terms of one variable. We have reduced it into two variable equation where we have one variable on your left side and we have one variable on your right side. So we can differentiate area since it is the required parameter. We have the maximum area, so we can differentiate area with respect to length. So we have area is equals to 20L minus L squared. Then the derivative of A is equals to 20 derivative of L minus 2L derivative of L. Then we will divide A into derivative of L. So we have derivative of A over derivative of L equals to 20 minus 2L. To maximize or minimize, we need to equate our differential to 0. So we have 0 is equals to 20 minus 2L. So our length is equals to 10. So now we can substitute the value of length to the formula of our width. So width is equals to 20 minus L. Width is equals to 20 minus 10. So our width is equals to 10. Now we can substitute the value of length and width to the formula of our area. So area is equals to length times width. Area is equals to 10 times 10. So our final answer is area is equals to 100 square feet.
That's all for this video. Thanks for watching. Keep safe.